Okay, so this lecture is a bit of a departure from what we've been doing. EPR and Bell's inequalities. In some sense, this is at the heart of quantum mechanics, or what they call as quantum foundations. And this is about at the very foundation of the quantum theory. What does quantum theory really tell us, or what it doesn't tell us? And in some sense, the nature of reality, about nature itself. So we can start with one of the questions. Let's say I give you I give you a wave function that can be broken down into the eigenstates of some observable. Now we know that with the probability absolute value of Ci squared, I will measure the system to be in the eigenstates psi I. Now the question might arise that just, and of course this will be, let's say psi i's were the eigenstates of operator A, in the sense I had a spectral decomposition lambda I, psi I. I'll measure the eigenvalue lambda I. So the question might be, just before the measurement, what was the value of the observable A? So I have a state vector, I am measuring A, and quantum mechanics tells me the statistics of the I outcomes. With the probability, I'll collapse the system into a certain state, and this would be the eigenvalue. But it doesn't say that just before the measurement, what was the value of the observable. So for example, one can take a concrete example of a wave function. Let's say this was a wave function